Hello friends, welcome to the 8th tutorial of Java online course. In last two videos we are talking about the classes, objects and different concepts of object oriented programming in Java. Now the third and most important concept of OP is the inheritance. Okay, so inheritance, in first video we have seen what do you mean by inheritance is. Reusability is one of the most important and useful advantage of object oriented programming is. It means using something again and again without creating a new one. Java programming language supports this concept. The reusability can be obtained by creating new classes and reusing the properties of the existing class. The mechanism of deriving a new class from the existing class is called as inheritance. The old class or existing class is called as superclass and the new class is known as the subclasses. Okay, if you are already aware about the C++ or any other object oriented programming language, you might be knowing this particular concept. Already we are defining a class and its properties. What property actually includes? Property means the variables, instance variables and the instance methods which you declare in above classes. We can reuse again them in the below class also. So generally base class, derived class concepts are given the names to them, or we can call them as subclass or the superclasses. So this is what we call as inheritance. Though inheritance seems simple, it's very effectively used in Java programming language. Almost everywhere, every program is carrying the concept of inheritance, and one of the most useful property used in almost all technologies under advanced Java programming. So try to focus completely on that, how exactly we are going to make use of inheritance and what are the properties, types and the usefulness of inheritance is there. We'll talk about this in this particular video and the next video also. Okay, so there are total 5 different types of inheritance available in Java. So first is single inheritance, like only one super and one subclass is present there. Second is multiple inheritance, where several superclasses and one subclass is available. Third is hierarchical inheritance, one superclass with many subclasses are present. And fourth is multi-level, so multiple levels are there, 1 to second, second to third, in that way. And the last one is hybrid, combinations of about 3 types can be like hybrid inheritance is present there. Okay, out of it here multiple inheritance is not possible in Java. Okay, multiple inheritance is not possible. It means that one subclass and multiple superclasses, that is not possible. We are going to implement such kind of hierarchy with the help of a concept called as interface in Java. That also we'll talk about in another video. Hierarchical is just like a tree wise structure we are having. So one root class is present, that is a superclass, and multiple subclasses are available after it. That is what we call as the hierarchical inheritance. Okay, so let's see how to create the inheritance in Java. So we are introducing a new keyword again, that is what we call as extends. So a class can be derived from another class with the following syntax, like class subclass name extends superclass name. So first subclass we have to define extends superclass. So whatever property of superclass is containing, all that will be inherited into the subclass. Along with that, it will contain its own properties also, like it will contain its own methods as well as own variables also inside it, and that can be used by creating the object of these subclasses. The keyword extend specifies that the properties of superclass name are extended into the subclass name. After this, the subclass will contain the methods of superclass and it will add the members of its own also. Remember, we cannot extend a subclass from more than one superclass. Okay, that is what we call as multiple inheritance, which is not allowed in Java programming language. Okay, so let's see the applications with the help of simple programming. So 2 examples I'll be showing over here, simple inheritance and one called a single inheritance. How exactly we are going to make use of these particular properties here with simple examples. So let's go to the NetBeans. Okay, so here I have created one package, inheritances, and then we're going to use it. First is simple inheritance. Yes, so let's check it out how exactly simple inheritance will work. Okay, is an incorrect package, so we are going to apply the package here. Package is inheritances. Okay, now yes, so I declare a class here called as super. Check it out. 2 variables are declared inside it, I and j. Inside that I am having a method show. This show method is just used to print the value of I and j. Okay, nothing else, no operations are done apart from that. Then we are going to have another class called as the sub. Okay, so any name can be provided, not required. Okay, it should be the sub name should be there. Class sub extends super. Okay, so super is the name of the super class. Remember, super S is capital here, here also S is capital. So class names must carry the first letter capital, that we have already seen. So this concept you need to carry forward in all the programs. Okay, so extends. And now inside subclass also I am having a variable k, and I am having a method called a display, which displays the value of k on the screen. And one more method called as sum. Okay, now what sum does? Sum is performing addition of I plus j plus k. Now look at this. This class contains only k, and I and j are present in this variable, in this class, sorry. And so I'm performing addition of this together here. So how it is possible? It's possible because of inheritance. So we have extended the properties of this class into this class. So I and j as well as show method will be available to use inside this class. I am using the I and j here. I'll show how to use the show also. Show can be used here by creating the object of this particular class. So let's see, this is called as reusability. And now let's see how exactly we are going to make use of simple inheritance. A is object of superclass, B is object of subclass. Okay, so A dot I am putting 5, A dot j I am putting 12, and then I am printing A dot show. It will print the value of this 2, which I have declared here for A, I and j. So here I and j they are declared, and show will be called. It will print 5 and 12 over here. Now after that I am creating another object, which is subclass object. Now what is advantage of subclass object? Subclass object, as I shown, it is reusability. So I and j are declared above in this class, that can be used in this class also. So now B is the object of subclass. It can use I as well as j and its own k also. So it contains 3 variables now present inside it. I can reuse these particular properties or variables inside this class. Now see, contents of this subclass. Now here B dot show, we just can talk see this one. This is what we call a reusability. Show method is declared in above class, which print the value of I and j. Here I and j is printed here by using show method, and display method belongs to its own class. It's displayed over here, it displays the value of k. And calling sum method also. So sum method is performing addition of this 11 plus 13 plus 17. Okay, that's what we are getting out of it, 41, and that will be printed by calling sum method. So show method is superclass method, display is subclass method, sum is also subclass method, but it's accessing the superclass variables also. Okay, that's how we are going to make use of the inheritance. Okay, so the classes are connected together with the help of the keyword extends. By the extends keyword, properties of the superclass are extended, inherited, reused again in the subclasses. Okay, so let's see the output of this particular code. So when I run this code, I just can see the output of first A. Just a minute, what's the problem? No, okay, check it out. So contents of sub 11 and 13, and case 17. For this case I am doing addition of these 3. For second case, which one? Which is shown over here. Fine. So in this way, a simple inheritance can be created in the Java programming language. Okay, so you can try this program, make the modification, add the variables, or then check how exactly the mechanism of inheritance works here in Java. Now let's go for some practical application of it. That is what we call a single inheritance here. A simple small program I have created here, by which you can understand the practical application of the inheritance. So look at that. I have created 2 different programs, classes. First class, this one, and this is second class, which is inherited from the first class. So first class, this is second class, which is inherited from the first class. Fine. Here I declare one variable, here I declare one variable mem, here I declare one variable val, and first class contains a method called as init, which is used to initialize the value of val. Okay, I'm reading the number from user and storing in the variable val, and I'm doing the square of this by using the square function method. Int square return that val into val. So whatever val that object is containing, it is multiplied by itself, and square is generated and returned from this square function. Fine. This is the first class. Now first class is extended, inherited into second class. It is containing mem, and now it is having a cube. Now what it is actually doing there? So cube is identified. Square means it will call this function here into val. So obviously it is doing val into val. square is called here, it means val into val into val. So cube will be generated and that will be stored into variable mem and that will be returned from here. Okay, so this is I'm reusing the above square function into the below cube function. Okay, cube method. That's it, they are connected together. And now one thing we have to make sure that if you don't create object of this class, then also it is okay, because everything is now available in the inherited class also. If it is available in the inherited class or the subclass, then why to create object of this particular class? Okay, so that's what your logic is. So second class object I am creating here, second s is equal to new second, this is object created, memory is allocated to s and s dot init. So init method belongs to the superclass, but I can call this to initialize the value of variable val. It will ask to enter the value, store in the val. Okay, fine, val will be initialized for s, and now s dot cube. So cube function belongs to its own, where it's calling the above variable easily to perform the square to finding the cube of the respective number that we have entered. So cube will be found and that will be printed in front of this system.out.println cube, and cube will be present in front of this cube statement. Okay, so in this way we can create the concept of inheritance in the Java application programming. Okay, so you just can check out this program how exactly we have done, and if I run this particular code, see the output that I am getting here. Okay, enter the number, for example number enter 12. So see 12's cube, 12 into 12, 144 into 12, 1728, which I am generating. So here init method belongs to superclass, then also it is get called with the help of object of the subclass also. Okay, and then cube I am accessing this above method here. Even I can access the square method also here by using s dot square. If you want to print the square of that number, see it's very easy to do, it's possible because the method we can reuse. So let's find square. Square is s dot. So you just put s dot, then it will show the methods of it. See, cube method is available here that we can make use of, and I want to reuse the square method. That's also possible. Check it out. See, so if I print a 12, its square and cube both are printed. So we can access its own method plus the method from the superclasses also. This is what advantage, what we call as reusability of the code, which can be acquired with the help of concept of inheritance. The reusability can be achieved with the help of inheritance here. Okay, so let's continue with your presentation. Now a few more properties which are connected to the inheritance that we are going to demonstrate now onwards. Okay, very important concept, try to focus this on clearly on. A superclass variable can refer to subclass object. Superclass variable can refer to subclass object. What do you mean by this? A reference variable of superclass can be assigned a reference to another any subclass derived from that particular superclass. In many situations we find this concept very useful and very regularly applied. What does it means? See, if I am creating a reference variable of the superclass, I can assign object of any subclass to the reference variable of the superclass. It will keep the variables within that which are common in super and subclasses. Let's get an example of this particular concept, how to use this reference variable here. Let's talk about this. Okay, now the program which I have used before, the same program I am using over here, I have just modified this program a bit, and then let's talk about this particular concept. Superclass variable reference variable can be used to assign any subclass object to it. Okay, so how do? Same superclass I have declared here which contains ij and show method. Then subclass I declared here which contains k and display method and sum method. Okay, and now let's see this. This is superclass reference variable. Okay, superclass reference variable. Reference variable means it is not allocated with the memory, just a variable of type that class is created there. Okay, reference variable that we generally call it as. And now this is the object of this subclass. Sub b is equal to new sub. So subclass object is created here. Fine. And now so a is not having any memory allocated to it. Remember, it's just a reference variable. Okay, and now b is created with the data, so I can assign the data directly in this way, or I can use a constructor to assign, or I can use a method to assign. So I'm using this method this way directly by using the dot operator to assign the values to the object variables. Okay, now contents will be printed. B dot show will print value of I and j, and display will print value of k, that we have already seen here. Show I and j is printing and display is printing value of k only. Okay, now this is what we are going to have. Superclass reference variable can contain the subclass object. So A is the superclass reference variable and B is the subclass object. Okay, so A is the superclass reference variable and B is subclass object. Now when you assign that, A will be initialized and it will contain the contents of B which are common in both. What is common in both? Okay, the common in both are, like, it contains I and j and it contains show method. Okay, it's common in both. Show can be called by this object also and this object also. I and j can be used by this object also and this object also. So which are common in that, only that will be copied. So let's look at that. B, contents of B will be copied into variable A, object A. Now object A is initialized this statement, superclass reference variable. So is created. When you assign the object, the reference variable will go on object's face, and now by using the reference variable of A, I can access its methods A dot show, and see, so sum will be accessed by B. B dot sum, A dot sum is not possible, but now when you assign this one, B dot I is copied into A dot I, B dot J is copied into A dot J, and A dot show will be there just like B dot show. Okay, so this is how we can assign the things which are common, they are copied. So now I can use show method to access it, because show belongs to its own superclass. So that method can be used to access, and now I can print the value of I and j by using this particular method. So if I run this particular code, check this. Okay, so this is what superclass values 11 and 12. In subclass also same values are there, but 17 is not present because k is not present in superclass, and sum I am accessing with the help of subclass. This is how we can make use of. So the things which are common, only that I can access with the help of this particular concepts. Most of the time we don't remember the what to do with the subclass object. In that case, we can assign directly to the superclass reference variable also. This concept is reused multiple number of times so effectively in advanced Java programming. Okay, so just remember it, practice this, and try to understand what concept is actually created here in Java programming language. Okay, so any subclass, whether it is having single level or multi-level, it's possible to assign and get your task done by using this particular way. That is what superclass reference variable can refer to subclass object. Okay, now there is a special keyword associated with the inheritance, and that keyword is called as super. The keyword super has specially been added for the inheritance. Whenever the subclass needs to refer to its immediate superclass, the super keyword is used. There are two different applications of superclass are present: accessing members from the superclass that has been hidden by the members of that subclass, and second use is calling the superclass constructor. Okay, so just like this keyword is used to access its own class object. Super is used to access the variables from immediate superclass. Okay, variables, constructors and methods, all three we can access with the help of this super keyword. Now let's talk about the super keyword. Make sure it's a keyword, and let's see how exactly it is used. So it's actually it is duplicated, that's why I will use primary 1, secondary 1, primary 1, and here secondary 1. Okay, let's talk about this, what happened. Okay, invalid types. Okay, declaration, just a minute. Okay, can make use of this again multiple number of times. Invalid method declaration, return type required. Okay, sorry, it is secondary 1. Okay, that's it. Now check it out. One primary class I have defined here, which contains show method, cal variable and show method. It will contain the cal variable on the screen by using the show method. Can check it out. Now secondary class extended from the primary class here. So secondary is the super subclass, primary is the super class. Here also contain the cal variable. Now look at that, cal is duplicated here. So cal is present in primary also, cal is present in secondary also. Okay, so two copies of this is present over here, but I can separate them. So how? When I create object of this class, remember this variable can be referred by this dot cal, and this variable can be referred by super dot cal. Okay, that's what the difference is there. This object of its own class, and super means object of the super class that I can use. Okay, so now let's talk about this simply. How can I do this? Secondary one, it contains two parameters which I am using here to inherit or to initialize both of this, and here I am using a super.cal. See how cal is initialized here by passing this value, but its own cal means this cal is initialized here, and I want to initialize this cal, so I can pass this y value to super.cal. Now this cal is initialized. So this variable is generally termed like super.cal, and this variable is this.cal. Okay, and here I am displaying it, cal subclass cal, and if I want to call above method, so I can use show method. Show will print this cal and display will print this cal. Okay, it will always give preference to its own variable, but if I want to separate them in a single class, then I am using super keyword to separate them. So super will identify the member methods or the constructors from the immediate superclass easily. So this way you can do it. Now let's talk about that. Secondary, 15 and 12 are passed. So 15 will go to its own cal, and 22 will pass to the superclass cal, this one. Okay, that defined. And now when I call the show method will print 22, this is passed above here, and the display method will print 15, which is passed directly to this variable. So in this way. So this is how we can separate the variables with the help of the superclass. This is the prime first application of the super keyword here. When I run this code, you can check this out. See, superclass cal is 22, which I have declared by y, and subclass cal is 15, which I have declared by x, which are assigned there. Okay, and based on that we have separated these two variables by using super keyword. And one more thing is to remember that if you write this dot cal here, okay, just check it out, this dot cal, then also it's okay, fine, there will be no any difference present there. This dot cal means own cal, and super dot cal means the superclass variable cal. Okay, so this is how the differentiation between the variables are possible with the help of the super keyword. This is the first application of super that we can make use of. Now second application of the keyword super is to call the constructor from the above class, just like this. This keyword is also used to call the constructor from the same constructor from the same class. Okay, means different constructor from the same class, but super class constructor can be called with the help of the super keyword. So let's talk about the second use of the super. Here is that. Okay, so same I am just extended. Here I am creating a constructor called as primaries. Okay, int a, I am assigning that to cal. Initialize the cal by passing value over here, and show here printing the value of cal on the screen. Now secondary class, which is extending the binary primary class, and after that it also contains its own constructor int x, int y, and here is the use of super statement number 2, which I mentioned here, line number 14, super y. So value which is passed over here will be passed to the superclass constructor, which contains single parameter, and cal of this will be initialized. It's just like same operation we have done there, but by using super as a constructor. So this value I am passing to the above. So this cal will be defined by y, and this cal will be defined by x, initialized by x. Okay, find this. So same operation I have done, but remember that this should be the first statement in the constructor, just like in this also. This or super should be the first statement in the constructor, then only the constructor calling are possible. Okay, so in this way we can perform the operation of calling the superclass constructor here. Okay, fine. Now let's see, operations are same again. 15 and 22. So 15 is passed to its own cal, and 22 here in y it will be passed to y, and this will be passed above here. Okay, so cal will be initialized. So output of this particular code and previous code will be same. Check it out. See, 22 and 15, but the method which I used here is different. I am using calling the constructor directly from the superclass, and then I am getting the output as it is on the screen. Check it out. Okay, so this is the method. This is the way by which you use the super method, super keyword. Even one more thing, remember, it's not generally used, but I'll show that in method overriding. We can call the method from the superclass also, like super dot method name. So anything we can refer from the superclass with the help of the super keyword. That is the prime application of using the super keyword here in Java. Okay, so remember this concept. So you can try that systems. Now let's see the multi-level hierarchy. Now multi-level hierarchy, it can be created by the system which is shown on the screen here. Check it out. Class A is declared. then class B extending the property of class A, and then after that class C is extending the property of B. This is what we call as multi-level inheritance. Now in multi-level inheritance, all the properties of A are added in B and all properties of B are added in C. It means that C contains property from A also and from B also. Okay, so this is what we call as the multi-level hierarchy. So multi-level hierarchy can be created by this mechanism. Okay, so let's see the last example of this particular video, how to create the multi-level hierarchy. Okay, so let's see. Small simple basic example I am showing over here, that is class white. Okay, so white class is created which contains variable num and one constructor which contains one parameter is to initialize the num. Then red class red extends white and red constructor is there. Now whatever values I am passing over here, the same value I am passing to above class. Fine. Then it's printing the value, while print function I am declaring here, value of print will be printed. Now red is extended in magenta, so magenta extends red. Okay, it contains Maggie and parameter which is passed will be passed to super class. Okay, and that will be passed to above class, and here Maggie variable I am declaring with Z. Fine. In this way, so white extended in red, red extended in magenta. So white is containing num variable, red is containing, okay, no variables are present here. Whatever constructor it carries is passing these values above. Okay, magenta. Now see what happens when I create the object of this. I can access this num also, I can access this print also, and I can access this Maggie also. So this is how it is possible with the help of the multi-level inheritance. So let's see the inheritance how it is created. So let's check it out. Okay, so first thing I have created this one. So let's talk about this. So multiple classes I've added, but let's see. So I don't require this. I'll just remove this particular part from here. Just the part of overriding concept. We will see that in the next video. It's not required right now. Okay, let's focus on the multi-level inheritance only. Okay, let's see. So here I am creating the object of magenta by passing 96 value to it. So this 96 value will go here. Okay, it will pass to Z, will pass here. Okay, to this constructor. This constructor will pass this value here, and this num will be initialized. So num is the variable which is there in white, is available in red also and magenta also. So num is initialized by this. Then I am calling the print method. So print method belongs to this class. I am accessing here. So value of num is equal to num. Okay, that's what is printed, and then value of Maggie I can access by m dot Maggie. So this is how we can access its own variable above method, and here also I am calling the superclass constructors above and then above. Okay, so only one constructor is present over here which is finally called by this to this, this to this, and this variable is available directly in this class also, and its own variable is also present. And if you run this, we'll have this 96 printed here, and value of Maggie is also 96, because same value I am assigning to num also, same value I am assigning to the variable Maggie also. If I run this code, check this, sorry, 96. The same value I am assigning with the help of multi-level hierarchy. Multiple classes can be connected together with the help of this kind of concepts, which we call as the multi-level hierarchy. One of the way by which multiple inheritance is extended. Now see, one important thing I can mention here, the internal APIs, internal libraries of Java are also having this hierarchy connected deeply. So many classes are having 4, 5, 6, 10 superclasses to it, and that superclasses properties we can inherit easily to the below subclasses also. So we can reuse the properties, methods, and values inside the subclasses which we create in whole multi-level hierarchy. Whatever the classes are present, everything I can reuse again in the most deep subclass. Okay, that is what multi-level hierarchy is. So one concept is there which is connected to the multi-level hierarchy. We'll talk about that. It's called as calling sequence of constructor. Okay, maybe somewhere you require this particular concept, that's why I added in this particular presentation. When a class hierarchy in multi-level inheritance is created, there is a sequence in which the default constructors are called. Constructors are always called in the order of derivation from superclass to the subclass. This order does not change though super is used or not. If super is not used, then default constructor of each superclass will be executed. And now see how to use this one. This program, last program of this video is call constructors. So let's see, it's connected with the multi-level hierarchy here. It's very simple and sole program that we can make use of it here. Let's see, 3 classes, Grandfather contains the constructor, default constructor, basically no parameters are passed. This is grandfather printed. Then father is extended from grandfather. Okay, check it out, it's extended from the grandfather. It contains its own constructor called as this is father, printing it on the screen. Then child is extended from the father. Okay, it contains own default constructor, is printing this is child simply. Okay, nothing is done there. Now in the main, in your main class, what I have done, I am just creating the object of the subclass, the most deep subclass, that is child. So child Roger is equal to new child. Okay, so I'm creating the object only, not calling anything. So I am calling this constructor only, which is the last one. Fine. So can you predict the output of it? I am not calling this constructor, I am not calling this constructor, as it was mentioned on the slides. Okay, so calling sequence start from the top superclass and then go on using onwards. So here I am just calling the constructor. Fine. Default constructor, not talking about the constructor which are parameterized, only default constructors are there. Now see what can be the output of this particular code. Check out the output. So first of all, grandfather, the top superclass constructor is called, then second constructor is called, then its own constructor is called. It means that whatever you write in that particular constructors will get executed first in the sequence from top superclass, then its subclass, then its subclass, then its subclass, and it will go to the end. Okay, then your program will stop. Now what's the advantage of it? When we have to initialize all the variables of all the classes, make sure that you have to write this initialization inside the default constructor, so that everything in this particular classes will be initialized in the sequence, and then we can initialize all the variables at once by calling the default constructor of the most deepest subclass. Okay, so this is how the property is present for Java's multi-level hierarchy. Okay, this multi-level hierarchy that we need to remember. After this, we are going to see few more properties about the inheritance, like method overriding object classes, or polymorphism, and most importantly the data encapsulation or data hiding or abstraction. Till then, just try the program, and if you have any doubts, you can contact us. Thank you. Thanks a lot.